Chapter 4, Section 2, Identifying Missing Data. Handling missing data is an important step in data cleaning. If missing data is not handled properly, it can lead to bias, reduce the efficiency of algorithms, and lead to incorrect conclusions. In this section, I will explain why do we need to handle missing values. Then, we will go on to how to find missing data by Python. Predictive analytics aims to predict future events based on data. If there are missing values, the model's accuracy may decrease because important information for prediction is missing. In addition, linear and logistic regression assume that values are input for all features, so the model cannot be developed if there's even one missing value. We can deal with missing values by using algorithms that can make predictions even though the dataset contains missing values. For example, algorithms such as k-nearest neighbors, random forest, XGBoost, and catboost can automatically handle missing data. K-nearest neighbors works by calculating the distance between data points to identify the nearest neighbors. When a feature is missing for a data point, k-nearest neighbors ignores that a particular feature in the distance calculation for that data point. Random forest, XGBoost, and catboost are algorithms that consist of multiple decision trees. These algorithms automatically select the best branch destination for feature values with missing values. Even if there are missing values, these algorithms can make predictions by using other features. However, these algorithms will perform poorly if too much data is missing. It is because if there's too much missing data, there's insufficient information available for prediction. In particular, if there are many missing values in important features, the model will have difficulty in learning the pattern in data. Therefore, how to handle missing data is an essential task in data analytics. The first step in dealing with missing data is to check whether the dataset contains missing data, and which rows or columns contain missing data. As an example, consider this simple dataset. This is an employee dataset. It records the employee's name, age, salary, and department. When we display data in Python, the missing data is denoted as NaN. NaN stands for not a number. With such a small dataset, we can visually identify missing values. However, visual inspection is difficult for datasets containing more rows and columns. Using Python, you can inspect missing values with a simple code. After loading the dataset named df, let's apply the info method to display basic information about the dataset. The output of the info method indicates that this dataset has 5 rows and 4 columns. In other words, this dataset contains 5 observations and 4 variables. A list of column names, that is, variable names, is also shown here. To the right of the column name, the number of non-null data is displayed. Non-null refers to data that is not missing data. Therefore, the number of non-nulls is the number of data that are not missing values. If this is less than the total number of observations, the column contains missing data. In this data, there are 5 observations for name and department, but only 4 observations for age and salary. Therefore, it seems that there's one missing data in each of age and salary. Now, we see that age and salary data for one of the employees is not recorded. Whose data is missing? To reveal this, we can use isNull and any to show the rows with missing values. First, we apply isNull to df. This part checks each cell of the data frame df for missing values. Then, any axis equals 1 is added after this. This checks if there's at least one missing value per row. The axis equals 1 means that we are checking on a per row basis. That is, it checks if there's at least one missing value in a row. This combination identifies all rows in the data frame with at least one missing value in at least one cell and displays the information for that row. Let's take a closer look at the code that displays the rows containing missing values. First, the df isNull part. This part checks whether each cell of the data frame df is missing values. isNull generates the result of this check as a Boolean data frame of the same shape as the original data frame, df. In this generated data frame, each cell displays true if there is a missing value and false if there is no missing value. Next is the part where any axis equals 1 is added to df isNull any axis equals 1 checks whether each row contains at least one true value. If there is at least one true in a row, it returns true for the entire row. The result is a one-dimensional array of Boolean values for each row, true if it contains a missing value and false if there is no missing value. Let's go back to the original code. This code represents the data frame with the brackets containing the part of isNull combined with any method. Only rows that return true by this underlined code will be selected. This code displays only rows with index 1 and index 3. Thus, only rows that contain at least one missing value will be displayed. Info and isNull are useful to detect missing values, but only when the missing value is denoted as none. In real cases, missing values are often denoted in other forms. For example, they may be denoted as extremely large values such as 999 or impossible negative values like -1. In other cases, missing values are denoted by a string such as NA or not applicable. In such cases, info and isNull recognize missing values as normal strings or numbers, so they cannot identify missing values. We can use the replace method to replace the data in such cases. Let us assume that we want to replace the value 999 with none. In this case, apply replace method by putting it right after the data frame name and a period. Then, the parentheses are closed by inputting 999 to be replaced first, followed by none. And then, input in place equal true. We need to set in place equals true so that we overwrite the data frame. We can apply this method only to some columns by specifying the column names using square brackets. If, as in this example, The missing data is denoted in two ways, 999 and NA. Both must be replaced with none. Thus, when multiple values are needed to be replaced, we can use a list in the replace method to replace them all at once. After replacing the data, use info method to check the data information. The number of non-nulls for age and salary has been reduced to 4, indicating that the missing values have been correctly recognized. For some data, missing data may be denoted in other forms instead of none. Therefore, before preprocessing data, it is necessary to check the rules of data notation. However, metadata that specifies such information is not always available. So, in addition to using the info method to obtain basic information, we should also examine each variable's frequency distribution to determine its values and categories. Using value counts, we can display the frequency distribution of each variable. For example, let's apply value counts to the data. Here, we select and apply only the age column. From the output results, we can see that an extreme value 999 is included. If there's only one such case, it could be an input error, but if there are some, we can infer that the missing data is written as 999 in this data. In its default setting, value counts displays values and categories in ascending order of frequency. Thus, for example, with data with a larger number of observations, as in this data, it is difficult to visually find that 999, which represent missing data, is included. In this case, add sort index after value counts. Doing so allows us to sort the results in ascending order by value or category name. By setting ascending false in the parentheses of the sort index, we can sort the output in descending order. This way, we can easily see that the data contains two values of 999. We can now infer that the missing data in this data would have been inputted as 999. Thank you for watching. Please thumbs up and subscribe to my channel.